Hello. In today's lesson, our learning target is I can add and subtract polynomials. So we're going to do just that. So to start off, in our last lesson we went over what a polynomial was and some of the vocabulary associated with polynomials. So we should be up to speed on that. So let's start with just a really simple example. Suppose we have x squared plus 2x plus 4 plus 4x squared plus x minus 14. So the way that we add polynomials is that we pretty much just add what we call like terms. So what is a like term, you might ask? A like term is any term in the polynomial that has the same variable. So in this case, it would be two terms with x with the same degree. So for example, this term and this term are like terms because they both have something in front of an x squared. So those would be an example of like terms in this example. Then 2x and x would be like terms because they both have some coefficient in front of an x to the first power, because whenever we have just an x, it's implied there's a 1 there. And then 4 and negative 14 would also be like terms. So we could add those together. And just the key thing to keep in mind is that you cannot add together a term with an x squared in it and a term with an x to the first in it. You have to keep them separate. So what does our addition look like? So I'll write an equal sign here. We have x squared plus 4x squared, which is 5x squared. So we add the coefficients together. We add 4 and 1. Then we have 2x plus x. So we have 2 times x plus 1 times x, which would give us 3 times x. And then we have 4 plus a negative 14, which 4 plus a negative 14 is a negative 10. So this would be the answer to our addition of polynomials. So now let's do another example, maybe with some polynomials of higher degree. So suppose we have 6x minus 8x cubed plus 6x to the 7th minus 100 plus, say, x squared minus 5x cubed plus 5x to the 7th. So now we have a much higher degree polynomial here. You see we have each of these polynomials is of degree 7. But again, the process is the same. We just take terms that have the same variable and exponent, and we add them together. So first, let's look at our terms that are to the 7th power. We have 6x to the 7th plus 5x to the 7th, which is equal to 11x to the 7th power. Then our next highest order term is to the 3rd power. So we have negative 8x to the 3rd power minus 5x to the 3rd power. That would be a negative 13x to the 3rd power. We have no x squared term here, but we have 1x squared over here, so that just stays by itself. Then we have 6x here, and no term with x to the 1st power over here, so that gets left alone. And then we have minus 100, and no like term over there. So we have minus 100. And this will be our answer. So again, it can be a little bit tedious matching up the like terms like we did here with the terms to the 7th power and the terms to the 3rd power. However, the process is always going to be the exact same no matter what polynomial you have. Now there is one other situation we could have, which is where we have multiple variables in the same string of addition. So suppose we have 11x plus 3xy minus 4x squared y plus 9y minus 2x squared y plus 3xy plus 15x to the 4th. So what that is going to be equal to is, it gets a little bit more complicated because now we have these expressions with multiple variables in the same term. But if we still follow the same rule and only add like terms, everything is going to work out. So you see, let's add our x terms first. So our only one that we have with an x in it is 11x. So I'll leave an 11x here. And I find sometimes it can be helpful to, once you've added two like terms, or one like term in this case, to cross it out so we're not confused anymore. Next we have terms with x, y in them. So we have 3xy here plus 3xy here. So that would be 6xy. So again, we'll cross those terms out. We don't have to worry about them anymore. And then we have x squared y terms, which we have negative 4x squared y minus 2x squared y. So that is a negative 6x squared y. So I'm going to cross those out. And then all that's left is plus 9y, and then plus 15x to the 4th. So that is the answer to our problem. So you could cross them out, you could underline them, you could leave them alone. I just find it helpful to do something once you've added two of these terms, because it's really easy to forget a term, especially when you have multiple variables like we do here. So that is addition of polynomial expressions. Now let's do a couple examples of subtraction. So subtraction is pretty much the same deal, except there's one slight detail that we have to be careful of. So suppose we have y to the 5th plus 2y to the 3rd plus 14y squared plus 10y plus 28 minus y squared plus 18y minus 2. So in this case, again, we're going to match up like terms, but instead of adding them, we're going to be either adding or subtracting depending on the sign. So first, our y to the 5th term, we don't have any matching term over there, so we'll just get y to the 5th. I'll underline it this time to indicate that I already have dealt with it. Similarly, our 2y to the 3rd is just going to stay alone. Now we have 14y squared, and then we have minus 1y squared. So that is going to be a plus 13y squared. So again, I'll underline each of those terms. Then we have 10y minus a positive 18y. So that means we're taking 10y and subtracting 18y from it, because we have this negative sign here. So that's going to be negative 8y. And then we have 28 minus a negative 2. And since we have minus negative 2, I'm just going to underline those. 28 minus a negative 2 is equivalent to 28 plus 2. So you will get plus 30. And this would be the answer to our polynomial subtraction. So let's do one more example. We have 6y to the 8th plus 3y squared minus y plus 17 minus, let's say, negative 3y to the 4th plus 2y squared minus 19y minus 40. So another technique we can use when we have a subtraction is to distribute this minus to each term. So we're going to distribute the minus to here, to here, to here, and to here. So what that does is that means that we're going to leave this first term alone. And we're going to get 6y to the 8th plus 3y squared minus y plus 17. So here for our first term we have minus a negative, so that's going to become a positive 3y to the 4th. Then we have minus a positive 2y squared, so that will stay minus. We have minus a negative 19y, so that will become a positive. Then we have minus negative 40, so that will be plus 40. So now we're going to do the exact same process of matching up like terms, but it's a little bit easier now because we don't have to worry about messing up the sign here. So we have, this is going to be equal to 6y to the 8th, underline it, plus 3y to the 4th. Then you have a 3y squared minus 2y squared, which is equal to y squared. So I'll underline these two terms. Negative y plus 19y, which is equal to 18y. Going to underline those. And then we have a 17 plus 40, which is equal to plus 57. And that would be our answer. So use whatever method you prefer for subtracting polynomials. Just be aware that although the process is relatively simple, it is very, very easy to forget a term and make a careless mistake in any of these problems. So just make sure that you check your work carefully, be very meticulous with your documentation of which terms you've added or subtracted, and always check your work twice, because it's no fun losing points just because you made a careless mistake. So that is adding and subtracting polynomials. In our next video, we're going to go on to multiplying as well as taking the exponents of polynomials. So stay tuned for that.